Hello there, and welcome to everyone joining us for this latest IoT Central webinar. I'm Clive Maxfield, everyone calls me Max, and I'll be your host. In addition to being a practicing engineer, I also act as a technology consultant, author, speaker, and educator. I'd like to start our webinar by thanking ARM for sponsoring today's event. ARM is a leading supporter of the IoT Central community, and we're very grateful to have them as sponsors. Today's webinar is the first in a four-part series entitled Fast and Fearless, the Future of IoT Software Development. The title of today's installment is the IoT Software Developer Experience. In this IoT Central webinar, we will be discussing development challenges engineers are facing today, how the industry is helping to make IoT development easier, an overview of development processes, including cloud-based continuous integration workflows and low-code development, and what the future looks like for the developers building for the IoT. So before we begin, I'd like to briefly review the format for today's proceedings. The event's going to be 1 hour long. We have 4 panel members who I'll introduce in just a moment. There'll be a 10 to 15 minute Q&A session following our main discussions. And this event is being recorded and it'll be available on iotcentral.io tomorrow. I'd also like to encourage you to provide questions throughout the presentation. I will be reviewing and presenting these questions to our panelists on your behalf during the Q&A portion of the event. So now I'm very pleased to introduce today's panel members. Joe Alderson is Director of Embedded Tools and User Experience at ARM. Joe is passionate about designing the next generation of software development tools for the IoT, embedded systems, and machine learning. Pamela Cortez is a developer advocate and senior program manager at Microsoft. Pamela is focused on growing the hardware ecosystem and IoT development communities for Microsoft Azure. Ihor Doretsky is a developer advocate at Cloud Native Computing Foundation. Ihor is focused on Kubernetes-related efforts in the open source community. He is the product manager for Kubernetes, co-leading the product management special interest group that's focused on enhancing Kubernetes as an open source product. And last but not least, Kat Scott is the developer advocate for Open Robotics, the makers of the Robot Operating System, ROS, and the Gazebo simulation platform. Kat is the former analytics lead at Planet Labs and Stratius, and she was the co-founder of Tempo Automation and Sight Machine. So welcome everyone, thanks for joining us. Let's start with an open question. Why is the software developer experience more important now than ever? Who would like to go first? Anybody?
I'm happy to dive in there. So certainly from an IoT and embedded point of view, I think if you just think about the complexity that is expected of the devices nowadays, the hardware itself is more complex. The lifespan is the same as an embedded device, so we're expecting them to be in the field for years. The actual edge compute that they're expected to do is more complex than ever, and because they're connected, they have to be secure. And so the overall barrier to doing that software development is much higher, and therefore, I think the software development experience itself is vital to smooth that out and actually make it much more quick and easy to develop an IoT device. So I think the software tools that are required in this space, it's inspired by the same kind of thing you see in web development. It's just as important there, and I think really in the embedded space there's an opportunity to bring in some of these kind of testing workflows and integrations that will make the overall software development much quicker.
Interesting. Pamela?
I would love to add on to what Joe was talking about, kind of reducing the complexity of building an IoT solution. For the fellow data nerds out there, we're looking to unlock about 80 billion devices on the internet by 2025. So that's about 150 to 100,000 IoT devices per minute. And so you can imagine, since there's going to be a lot of devices going online, we, already have a skills gap. And so we're seeing that in the industry now. We're seeing, especially the cloud side and connecting devices to the cloud, we're seeing about 30% of customers and partners saying that they would love to build these IoT solutions, but there is this huge skills gap. So not only are we have these new devices and skills gap, we have all of this new innovation that's coming online, like Joe was talking about, like especially bringing AI down to the edge side. This new skills that are needing to be developed on top of having a skills gap. So I really think if we can, kind of help have a better software developer experience and also make it easier, as Joe was saying, we could really help everyone get started, build a proof of concept, and don't go into production quicker, and have a higher success rate of being able to do that as well, and be able to continue to innovate on top of that. So yeah.
I'm glad I'm not a developer anymore. I was never a software developer. I was a hardware guy. But life seemed so much simpler in the old days. You wrote code to run on bare metal. You didn't have the cloud. You didn't have security issues. You didn't have artificial intelligence and machine learning. And I pity today's younger developers, to be honest. Ihor.
Yeah, well, I would say that you still need enough skills as you had to have them in the past. Just the type of the skills is different. So I'm gonna wear my developer advocate's hat at the cloud native ecosystem, and I definitely want to mention that, like, if you want to develop something for IoT or edge devices these days, you may be required to have some essential skills outside of the hardware, outside of the hardware ecosystem. At the same time, having the skills in specifically the software development will allow you to understand how do these things work, and they will also allow you to run some software not only for the IoT or edge devices, for example, but for something bigger, like for cloud and so on. Definitely want to mention some abstraction levels like Kubernetes, which is widely used around the globe these days, and definitely this tool was designed not for the IoT cases and not for the hardware cases, but today, in like 6 or 7 years after its inception and being so popular, it's widely used in this environment as well. So you definitely need enough skills for the software development, but it's a little bit different skill set that you may require in the past, and that's it.
It sounds easy when you say it like that.
Well, it is easy, but yeah, it may take some time for you to be aware of it.
Well, I'm the lone roboticist versus IoT people, but it does seem like it's sort of the Wild West out there right now, and there's not a lot of standardization. There's no clear-cut way to get from A to B, and so improving experience kind of just helps people get things done. I mean, when it's such a new field that when you go and try to like use your normal skill as an engineer to go Google, how do I do this? You just get inundated with a lot of information and a lot of not so great information sometimes, a lot of marketing. And it's very difficult to pin down exactly how to do something, to find that sort of engineering honesty on how these things get made. And open source is always great because you can see how it's made, you see how other people are using it, why it's out there. And I think that really can help smooth things over, because you can go look at the source and say, well, here, I want to do this. Here's this other thing that looks kind of like the thing I want to do. And you can use it sort of as a starting point and a starting template for your development.
Right, and you say that you're not so much an IoT person as working with robots, but it seems to me that robots are almost like the ultimate IoT device.
Yeah, the way I describe it, right, is the sort of old definition of a robot, right, is that you have some sort of sensor, you have some sort of actuator, and then you have something in between connecting the two to do something interesting. And I think, we build robot operating system in ROS, and ROS is basically, it's for robots, but it's anything that fits that broader rubric of sensors, actuators, and sort of control. But the robots are coming more and more online. Like everyone's, they don't have the storage capability, and they're finding too many new and interesting things, and things are changing so quickly that you actually have to have the device on the internet because you need to update it, you need to change it, you need to like respond to situations and coordinate.
This is another question that's sort of related. The first one was, why is the software developer experience more important now than ever? And a related question, what do you see are the biggest challenges facing developers building IoT devices today? Let's go in reverse order. Kat.
So biggest challenges? I mean, I think it goes back to, we've talked a little bit already about there's information overload, there's a skills gap, right? There's just a lot of misinformation out there, and it ends up one of the more difficult parts of any project is just getting started. And so like narrowing that broad spectrum of things down to the set of things that you can focus on to get the job done is still really, really difficult. And it's hard for people to sort of evaluate technology and say, well, here's A, here's B, which one is going to work the best for me? And I think we still don't have a lot of clarity around that.
I'm scared that we'll start using artificial intelligence to make those decisions for us.
Yeah. At second Kat's point about how to get started, probably this is the biggest challenge for every single developer in the globe, not only focused on the IoT devices and in the related areas. So what should they do to pass the first stage? And after you've did it, your road will be way easier than it was at the beginning. So this is definitely one of the most important challenges for various developers in this space.
Okay, Pam?
I think I see a couple challenges when coding with partners and customers. And one of the things I notice is, especially when we talk about bringing intelligence to the edge and running machine learning models on edge devices, is actually bringing the teams together. Because normally these are teams that never worked together before. Maybe they're teams that have been working with AI or doing machine learning models on the cloud side. So they're used to using different programming languages, different tooling. And then you have your hardware engineers or firmware engineers, IoT developers who are really close to the device. And so when you're trying to deploy these machine learning models, the education and the tooling's different, the terminology is different, how you do DevOps, there's so many things. And so just I've seen teams just try to learn the different languages, and even as basic as, hey, I'm not saying this is basic, but on an edge device, if you're running MCU versus an MPU, like a small footprint device versus a bigger, beefier device, try to keep it as layman's terms, but the AI model is going to look different. The machine learning model is going to look different on those different devices. And those teams might not have the expertise to understand that. So it's really bridging the gap between the two teams. And then some of the other things I notice is connecting hardware to cloud. So anytime you have like a dev board, you're kind of in your own little world, and then the cloud solution developers are in their own little world, and bridging the gap there where, if you're connecting a device to cloud, you have a lot of the hardware companies now working with the cloud provider companies like Microsoft, with Azure, AWS, with Amazon, Google Cloud. They're working directly with these silicon partners where they can actually make it from going from like a day of development trying to connect a device, or even up to a week just trying to send a device to the cloud. But those two companies working together, now they can get the experience down to 5 minutes. And it's because all of these communities are coming together to try to integrate the products and services, so it's easier for developers to get started quicker. So it's the partnership between all of these different companies and communities I see kind of help with those biggest challenges. But if we didn't have that, it's really difficult to get any device connected to the cloud without that support.
True.
Yeah,
Joe?
yeah, I was going to say some really good points, I think, made there, and particularly the prototyping stage is something that we've seen has been quite challenging for people when we've done research into the kind of prototype to production workflow. But going from having a working prototype to actually a real production device that's been provisioned with credentials in a more kind of secure factory production line sense. And then going through things like the in-field testing and the EMC testing, and then actually the device lifecycle management, all of those things are sort of part of the overall prototype to production workflow in IoT that I think introduce new levels of complexity over and above what you might have had with traditional embedded development. And even driver porting, things as simple as that can be quite challenging and time consuming today. So there's a lot that can be done just in terms of defragmenting the software landscape, making it easier in terms of interoperability. And on top of that, you've got the traditional challenges like optimizing your bill of materials, because you've got to fit an IoT application potentially running a model into the smallest footprint MCU you can go for. So there's there's the traditional challenges as well.
Actually, I was going to challenge you when you said something about at the beginning that the prototyping was hard. I was going to say, yeah, anyone can build a prototype. Anyone can build something that works once. It's going to production that's the tricky thing. And the other thing these days is the supply chain and security, because you design something that is brilliant, but then you give it to a company that may or may not be secure. And what you get back may be not what you think you've got. There may be malware loaded onto that. With no matter what we do, there's sneaky ways in there. Since I've got you all here, and since a lot of people will be seeing you for the first time, I'd like to ask each of you now to share how you and your company's products are helping developers to overcome these challenges. And to back up Joe's point, moving to production quickly. So let's go back again in this order. Joe.
Sure. So ARM has quite a wide range of things that we're doing in the IoT space, from the hardware IP all the way up. And my particular area is looking at software development tools. But if you look at the command line tools that we're providing, the software ecosystem framework, so things like CMSys, all of those things are designed to make it easier to integrate into an overall workflow. And, we'll probably touch on, for example, doing more effective CI development later on. But the way that we're approaching development of command line tools and things like that means that they're easier to integrate into CI workflows, for example. And then on a sort of tools basis, looking at the software development tools that we have, we have mature IDEs like HileMDK, where there's almost 60% of HileMDK users are already doing IoT and ML development. So it's already being used for those kind of purposes, although it's a traditional embedded tool. And we know that on top of that, they're using the sort of middleware and the ecosystem frameworks that we provide. So that's kind of stuff that's a bit closer to my area of expertise within ARM. But all of that's in a much wider context of ARM bringing out hardware IP like the Cortex M55 and Ethos U55 that are targeted more at IoT and ML specifically.
Okay. Pamela?
Yeah, so I think with Microsoft, it's especially when it comes to IoT, we're meeting developers where they're at. So example for that, and I know that just sounds like a catchphrase, but really at the end of the day, what that means is myself and others, we're working very closely with different types of partners like silicon partners like Microchip and ST Micro, ARM, all of them, where developers who are used to their own IDEs don't have to download a totally different piece of software and upscale on this new software, get their tool chain up and running, where all of these products and services are actually integrated in sample code and it's ready to go, and the plumbing is already ready for them, the foundation with the tooling that they're used to. So that helps, developers feel, one, more comfortable. I think if you're embedded developer, I think we all have tool chain nightmares. And so being able to just have that experience go a little bit less painful for folks and easier for them to get started. And then I think, when it comes to the cloud side, since we know that IoT is more mainstream now, is that there's a lot of IoT things that are pretty standard across most IoT solutions. Like, for example, managing devices, managing certificates, doing over-the-air updates. A lot of those common subsystems when you're architecting an IoT solution. We started to look into and creating products like Azure IoT Central, where we manage all that in the back end for you, so you could just focus on being able to connect a device to the cloud through, open source SDKs, or working with the community or your partner dev boards, whatever that might be, in your own tooling. But once you get that data to the cloud, you're easily able to not have to manage those services, have Microsoft manage it for you, and be able to do the full device lifecycle. Because also being able to scale that out is one thing, like you were mentioning, going POC, proof of concept, to production, but to scale that out, to sit there and manage that full scale out, and even storage, all of that, and then being able to do over-the-air updates, send commands down to the device, having a piece of kind of software plumbing already ready for you to go, it's super helpful for folks. That way they can easily scale, because scaling can be a complete nightmare. And pricing too. I hate to bring in that kind of marketing end to it, but pricing, I can tell you, when you bring in all of these different elements like storage and all of that stuff, pricing actually is, strangely enough, one of the top things that I see from partners and customers, where if they don't understand the pricing model, it's hard for them to guess, going from one device to many devices, what the price will be, and that makes people back off on moving forward on an IoT solution. So I would say Microsoft is helping more on that side and working with communities, open source communities, and really trying to connect all devices to the cloud.
Yeah. I absolutely agree about having the modular pieces that you can pull together, because I come from the days where we didn't have anything. We didn't even have networks. This is pre-Ethernet. And I worked for a big computer company in the UK. And on one occasion I was invited, I was only a junior engineer, but I was invited to this display where they had a mainframe talking to, this is the year before the IBM PC, but it was a PC-like computer. And the editor, they opened a text file on the mainframe and wrote some text in and saved it, and then they opened that same file on the little computer and showed that it was there and changed it and saved it. This was such amazing, and they were using their own proprietary network. And this was such amazing news that reporters got the train from London to Manchester to report on it.
Yeah.
I mean, and now, so you had to develop your own network. You wanted two computers to talk together. You had to develop your own network. I mean, and if you were IBM, you wanted two of your own computers to talk together, it had to be the same generation, because they had different character sets from different generations. So having today's modular approach is key, and also having the robot operating system there, rather than having to build things up from scratch. You've got a core work that you can take, so you can build your secret squirrel stuff, the stuff that makes it different. Not spend all your days coming into work designing the same thing over and over again.
Oh yeah, we definitely see 80% of IoT solutions have the same code. It's, when you see that commonality with all of those solutions, you can help with those core subsystems. That way people aren't reinventing the wheel, like you were saying, Max. Yeah.
Yeah, but then the fun stuff is the idea in your head, making that work, and all the other stuff for me as a developer is the boring stuff. So
yeah,
secret sauce is incredibly important. especially if you're a small company. You have to be able to do things quickly. I mean, I think from our end, that's what we enable, right? We're the sort of neutral third party in the open source community that sort of sits in between and says, hey, we'll help keep track of where all the source code is, all the different modules that people want, centralize sort of the development process and standardize it for the core components, and really make it possible for people to just focus on the thing they want to build. You know, it's amazing what you can do when you don't have to worry about like logging systems and, you know, startup scripts and visualization tools and like just core networking capabilities.
Mm-hmm. Igor,
Yeah. Yeah, gonna add a little bit from the different side, because with the projects that are hosted under our foundation, under the Cloud Native Computing Foundation, we are a little bit far away from the hardware itself, so we're mostly focused on the software projects and products. And most of them have been actually developed even not with the IoT devices and with the edge computing in mind, but many of them have been adapted to this era later. So we have conducted the edge micro survey across some of the consumers in our area, and we've actually heard from people that most of them are using Kubernetes for their IoT services. It can be somehow surprising, like especially if we're speaking about Kubernetes as about like some big and heavy and complex tool which is widely used in the typical data centers around the globe, but most people do not probably use or may consider using such a complex tool in the kind of specific environments as the IoT devices are, but people are using it. And specifically at the cloud native ecosystem, within the cloud native ecosystem, we have enough projects that have been spinned off of the Kubernetes project itself and are complementary to it right now. Many of you could have heard about K3s, for example. The K3s is the stripped down version of Kubernetes, which can be easily run on some, even on the small machines, or even like smaller devices like IoT devices around the globe. And this is like exactly the version of Kubernetes. It could be easily run, not in the centralized data center somewhere, like somewhere in Europe, for example, or North America, but it can be easily deployed on every single small device around the globe. From the other standpoint, as Kat mentioned, there is a big desire, and there's a big desire for people also to maintain their applications, to understand what's going on with their IoT applications and so on. So we have enough tools from the observability standpoint, the monitoring tools, the login tools that allow you to understand what's going on with your applications that have been run on the IoT devices. Such tools as Prometheus, FluentD, and so on. So in this ecosystem, even again, despite the fact that these are not most of these tools are not originally developed for these specific hardware use cases in mind, they've been easily adopted by the wide community.
Mm-hmm. One thing that just struck me, actually, listening to everyone talking, was that things change over time. And if you go back a long time, there were small companies like Hewlett-Packard that started literally with 2 guys working in a garage. And then things grew and grew and grew. And sort of when I was coming up, the only way to get things done really was to have a huge company where you had the design side, you had the people doing the circuit boards, you had massive departments to do everything. And now we're back to having, well, I mean, we've still got big companies, but what's causing the explosion of stuff in the IoT space is small companies popping up with great ideas. And again, they can't afford to redevelop everything. They have to take modular building blocks. But the stuff that's coming out from small companies now, it blows me away sometimes. So we've got some questions here. What are the biggest opportunities for today's IoT software developers. And one, of course, is intelligence at the edge. I read somewhere recently that there are 22 million software developers in the world. A lot of those folks are working at the high-level application type stuff. I know it's very hard to count people like this, but I heard that there were 1.2 million of those were the working at the firm level, the embedded systems level, the firmware level, the lower level code. And out of those 1.2 million, 0.2% have got a clue about artificial intelligence and machine learning. So the big question now is that because everyone wants to put artificial intelligence and machine learning at the edge, what's your advice for that? How do you get into this? How do you learn about it? Joe?
I mean, I would point to some of the smaller ecosystem partners that ARM has at the moment, actually. So, you know, if you look at Edge Impulse or if you look at Cartesium AI, you know, there are companies offering really quite usable platforms to take training data, generate models, validate them, roll them out to devices, and they're outputting models as a C++ library or a library that will integrate with Mbed or with Arduino, and it makes it so accessible. You know, it's really, really compelling to go and play around with those kind of frameworks, and really powerful as well.
Yeah, so you should mention Cartesium. I was just looking on my desk. Somewhere around here, I've got a little AI application I created using Cartesium. And I'm not a software developer, so if I can do it, anyone can do it, to be honest. Pamela?
I love that Joe mentioned Edge Impulse. I was actually going to have that as my answer too. but I think if I kind of just back up, I just want to make sure, you know, ask the question, does AI make sense for what you're trying to build? I would just want to pose that question, because sometimes I hear, you know, folks starting off like, I'm going to deploy this machine learning model on this microcontroller. It's like, great. What's the goal? Does that make sense for you to do? Because I think it's our first instinct to be like, oh, here's this new thing. Let's make sure to plug this into our solution. And lots of times, you know, it's amazing to have in solutions, but I just always want to start off with that, because we don't need to have every AI on every single device out there, but there's huge benefits of doing that. And so one of the things that I really love is that the hardware is catching up, because before you couldn't do a lot of, you know, bringing machine learning models. There's still, you know, best practices. There's still kind of a long ways to go with best practices. I still feel like what Kat was saying earlier, the wild, wild west type of mentality there, you know, so I still think we've got some while to go before we have best practices, but we have amazing folks like Joe mentioned, like Edge Impulse, who are really going those smaller footprint devices. And then you have NVIDIA with their Jetson line coming out, where if you want to do a little bit more beefier things or more processing on the edge. So I just love the fact that we're starting to see the hardware support these applications. And then there's times where, depending on your solution, you might need to store data for a long period of time. Oh yeah, I normally always have we're twins with their little Jetson Nano devices on our desk. You know, AI is so broad. The applications are so broad. So I would say you are a company that has a train and you're doing video processing on the edge, but you're in the middle of nowhere, so you need to store that data. So you're going to need a totally different piece of hardware to be able to have that amount of storage in it too. And so there's a lot of things to think about when it comes to AI, and then if it makes sense for your solution, what type of hardware. So it opens up kind of a new set of challenges, and then it's hard to find best practices of where to get started there. But I love the fact that you can go to Hackster.io and other places, and you're starting to see a lot of people make great examples, and the community is starting to build in this space. And so you can get started pretty quickly on just playing around with it. Yeah.
Yeah, no, I totally agree. Edge Impulse, again, Cartesium, they appeared from nowhere to me, and they just blew me away with what they've got. The model, I created a model that could monitor my Hoover. It was really so that when my son is hoovering at home, if the bag gets full, it would actually send a message to my phone so I could call him and say, change the bag on the Hoover. But the model was 2K of memory. I mean, which just, again, blows me away. Ihor.
Yeah, first of all, I definitely agree with Pamela that the first question you have to ask, ask yourself, do you really need this? Like tools tools and implementations for AI and machine learning, sometimes they add extra complexity, and sometimes you really do not need it. But from my experience, like in use cases when people really need them, in my personal in my personal list of preferences, and I have one single project that is an absolutely great implementation of how can you combine the best of the software development world, of the machine learning world, and this project can be also potentially expanded to the IoT world. This project is called Kubeflow. I'm sure like if many people have heard of it, but this is essentially the implementation, the TensorFlow implementation on top of Kubernetes. And this is an amazing tool, even for those people who are looking for implementing the machine learning pipelines on their IoT devices, their hardware devices, in a most efficient way by also using the same software development technologies what they would use for the regular development for just the basic cloud native applications.
Mm-hmm.
So this is like one of my personally preferred tools in the AI and machine learning space, and I'm really excited also to see this tool being actively used in the hardware ecosystem as well.
And Kat, how would you recommend people get into AI and machine learning stuff?
There's a lot of sentiment to echo. My background's actually computer vision. I'm generally very skeptical of edge devices, right? And it's just seeing like people have a hard time right sizing like the compute they need, and generally also like there's this problem of new and shiny versus cost effective and decent, and also where you put the compute, because sometimes it doesn't need to be on the edge. Robotics is the edge case, where often you need a lot of horsepower with a lot of power consumption constraints. So we do see a lot of it, but I get, it's some complex math. It's a lot of thinking. It's a very difficult field, and I don't think people necessarily always match the right tools, match the right hardware, match the right data set size and quality of data to the actual applications. And it's very easy, like people have said, it's very easy to get something that works once or twice. It may randomly work correctly once or twice, but getting something that really works deployed is very, very difficult. It's very easy to make machine learning models that are 70% accurate. It's another thing to make something that's 99.9% accurate that you can put on an assembly line or in an application that's mission critical.
I agree with all the points that you have to make a decision, do we really need AI? Because again, I lived through the 90s where everyone, it was like gluten-free. You go to the supermarket now and you see gluten-free washing detergents, and you go, I didn't know there was an alternative. And in the 90s, everyone started slapping AI on everything, and it was really expert systems and nothing like what we have today. And so it got to be a bit of a bad name, but I'm also experiencing AI more and more in my own life, and I can see The example I use when I'm talking at conferences would be a toaster that's equipped with speech and vision, where the toaster gets to recognize all the members of the house. You know, when you first unpack it from the box and plug it in, it goes, "Hello, who are you?" And you go, "Max." And it doesn't keep up a conversation until you put some bread in it, and it recognizes the sort of bread. So you don't have to tell it this is brown bread or white bread or a bagel or a muffin. It knows. And it says, "How do you like your muffins?" And I go, "Oh, yeah, they're quite dark, please." And when it returns it, it says, "Is this dark enough?" And I go, "Maybe a hair darker next time." But it learns everyone's preferences. Because when I go to our toaster at home, if I don't check to see if my son's been there before, I get a piece of soggy bread because he barely toasts it at all, and I like it quite crisp. And it'd be nice if the toaster recognised who was using it. And it's a simple application, but I can see artificial intelligence making my life a huge difference in the kitchen with the toaster. Call me crazy.
Well, I think you could do that with an off-the-shelf MCU. Like, it's not. Some of these deep learning methods are overkill for simple applications.
Well, true. Why should a developer consider cloud-native DevOps practices?
Happy to take this one.
Okay.
As a person from the cloud native space, so yeah, I probably have some insights from the area. But the biggest benefit here is that it's essentially almost the same that I mentioned before during our conversation. Is that you can use the same vision and the same model of development, your software applications that you use for the regular cloud development, for the regular software development. You can also implement the same vision and use the same vision and implement the same practices in the hardware development, in the IoT development, and so on. So when you're using the cloud native tools, you can develop some kind of application, try it on your laptop, which is using, for example, the ARM chip, for example. You can also run the same application somewhere in the cloud, which are x86-64 native, for example. And you can also run the same applications somewhere on the edge or in the IoT ecosystem, in the IoT environment. So basically, if you're using the cloud native tools, you are adding this necessary level of abstraction where you can like develop once and reuse it multiple times in the various heterogeneous environments.
Mm-hmm. Okay, I've got so many things to ask and we are time limited. So what I'm going to do, when I ask a question, I won't go through each person, but anyone who wants to answer it, just wave your hand and start talking. So next question, how are load code or no code platforms affecting the field of software development? And what are the opportunities for developers? And not as a software developer myself, what is low code or no code platform?
I mean, these are the services like Lambda and things of AWS Lambda that are, you know, easy to implement a trivial service and put a REST API behind it. I think they're interesting sometimes. They're interesting in a hacking, getting stuff together. They're also intimidating in a cost-benefit analysis. To get something working quickly, they always seem to be like, oh, well, that's kind of cool. And then at the same time, if my engineer came to me with something like that in production, I think, and we were actually had a lot of customers, I think I'd be terrified. That's at least my take.
So this is where you just use an API to call stuff that other people have developed? Mm-hmm. Okay. Does anyone else have anything on that one? Or
it's just, I think it's interesting in the industry as a whole, because you've got a whole generation of people who are growing up having maybe learned a bit of Scratch in school and, you know, started out with a microbit. And I think, you know, that demonstrates how low code can be really effective as a learning tool and to get to grips with some of the basics of programming. And I think when it comes to the sort of more mature implementations, really, I think the embedded space has some way to go in terms of like really mature underlying command line tools that companies can build on top of, so that you eventually get to that point of automation where you can have low code that does what you need it to every time.
We've always had low code, right? We've always had scripting language, so like what, MicroPython or something like that, where it's just, okay, I'm just writing a whole lot. Like anytime you write Python versus C, I think you're saving about 10x in terms of lines of code, right?
Mm-hmm. Yeah, interesting. I had a thought that popped into my head there and it popped out again, but if it pops back in, I'll tell you. How important is open source for software developers these days?
Super important. So I was saying that there are two kinds of software developers. There's basically open source developers and liars. At the end of the day, right? Everything will end up pulling in some degree of open source at some point in core components. And so it's incredibly important. And I think, starting a project with a plan for what you're going to do and how you're going to use open source and how you're going to interact with that community is huge. Like if you're building a product that's developer focused, you almost have to have open source to do it well. That's sort of the situation right now. It's very rare, I think, to see people working entirely on a proprietary software stack. Things are just too complex to do that anymore.
I've remembered my thought. Yeah, sorry, Pamela, I'll be with you in a second. I read somewhere, I think it was about a year ago, and I think it was a company like Facebook had come up with an AI-enabled tool for coders that when you started coding a function, it went out on the internet and it didn't find exactly the same function. It found people who were doing something similar and brought these examples in so you could see what other people had done. Which I thought was quite interesting as an idea. Sorry, Pamela, over to you.
Thanks, Max. And I totally agree with Kat. I would, for open source, mostly my background is open source hardware. So I used to work at SparkFun Electronics. And so a lot of the things we saw there was you're kind of speeding up innovation and you're getting more people who aren't traditionally developers or come from that background being able to create boards, because a lot of those footprints or a lot of the schematics and Eagle files were shared. So after you develop a board, you open source it. Now I can take this basic, breakout board or dev board and make my own product out of it and, be able to keep open sourcing. So it's just that sharing of information. And then so folks don't have to go back to reinventing the wheel, but they can also share to the community, helps bring in new folks who traditionally aren't developers who want to contribute. So I think there's so many benefits of open source when it comes to that. And then on top of it, I can't tell you how many folks who start off IoT solutions just from open source projects, from like the maker community and just learning that way. And they're learning a little bit about the hardware and connecting it to the cloud, all because they saw a tutorial on Hackster.io or other places or GitHub and followed along. And then they built on it and then helped contribute back to the underlying foundation. And so I'm a huge fan of open source too. So I'm gonna try not to keep talking about it because I could talk for days on that as well. So it's just a great way to share your information out and upskill it too.
Just to jump
Sorry, Joe.
I was going to say, just to jump in quickly, Max, you pointed out earlier that companies like Edge Impulse or Cartesium have kind of come out of nowhere in a way, but I think it's really interesting to think about the open source frameworks that they're leveraging and building on top of for their solutions. I think it's almost like, you say you can't do these things without the big IT department, but actually there's some really, really fantastic open source projects that underpin some of these more exciting startups nowadays as well, like TensorFlow itself.
Well, yeah, TensorFlow, that blew me away when I saw that. I'm keeping an eye on the time, and time is the most precious thing we have these days. A more integrated approach to hardware and software development is expected to improve performance, reduce development times, and encourage innovation. How can software developers get closer to the hardware community?
I would have an initial kind of answer from an ARM point of view there. So one of the things that we're looking at the moment, and actually there's a blog post on the ARM community back in February around this, is actually running tests against models. So we have these things called fixed virtual platforms, which give you like a programmer's view of an ARM system. And rather than having to have loads of dev boards on your desk, like all of us do here, being able to actually do the kind of continuous integration testing against something like a model actually saves a lot of time, because you're not having to just hope that your firmware runs on the board each time. You've got something that allows you to do tests on every single commit if you want to. And I think those kind of practices mean that there's less room for error when you get to the actual hardware itself. So having that kind of duality of being able to test on a model, but being able to deploy to a dev board once you're confident in it is really powerful. And I think that will accelerate things a lot.
Yeah, I could say from our side, just seeing the growth of simulation has always been really powerful to, if you have a robot, well, the last thing you want to do is have to be on the floor with a robot to compile and deploy your code. Like as soon as you can do that on your desktop like you're used to, it makes things go so much quicker.
Yeah, and last thing you want is a homicidal robot barreling down towards you and think, I should have checked that routine.
Safety concerns too. Yeah, there are situations where you have to scrap things up to test it, right?
Well, actually, that leads me to the next question. There's many technical challenges facing IoT developers. And one big example, safety, is an important factor when developing robotics. So what advice would you give to a developer who's developing an application in a new field and is having to overcome new technical challenges for them, like the safety thing? Now, Kat, that one sounds like it's new for you.
Well, I think safety and security go hand in hand. There's no doubt about that. There are, from the safety side, right, there are actual technical specifications about what it takes to make a robot safe. There's actually, Fetch Robotics just passed there's a new standard out on robotics safety, and they actually built the standard, and then all of their robots meet that standard. So that's one side, and then there's the cybersecurity, security side of robotics, which fundamentally people a good red team, a good set of security people, having them in your back pocket, being able to talk to them is incredibly important. I mean, I think there's some peripheral things around sort of edge compute and deep learning that also need to be addressed. It used to be we built robots and it had a very well mathematically defined control system, and you had a pretty good sense of what it did, what it would do in certain edge cases. And even if you weren't sure, it was in a box, right? It was in a metal box that couldn't hurt anybody. Now we're putting, 3-ton, 2-ton robots out in the street and hoping they don't hit people. So I think safety is incredibly important. I think simulation helps with that. But I think at the end of the day, part of it's just going to be addressed by policy.
Mm-hmm. I'm watching the time here. I think we're going to have to move on to the audience questions, otherwise they won't get a chance to ask any. So first of all, I'd like to thank everyone for this excellent discussion. We're going to get started with today's Q&A session. I want to thank the audience for their participation. I've been watching the questions coming in. We're going to do our best to get through all of the questions in the time remaining, but if not, we have a fallback plan, which we'll call Plan B, so no one gets confused. All right, so the first question: how do we decide if we need machine learning or artificial intelligence or not? Is it best to deploy without it and phase it in later? Pam.
I think it kind of goes back to what are you trying to solve? So initial planning, because I think it's to kind of start from the ending. The last part of that question is, should we just add it afterwards? One thing to keep in mind is if you're building a solution and then you decide to add machine learning afterwards, you might not have the appropriate hardware, and now you just spent 3 years in development of a new IoT device that you realize, oh, I need a different set of hardware to actually be able to run those machine learning models that I want it to do. But I think, you know, if you're looking to bring intelligence to the edge, there's a couple reasons why people do that. So are you looking for lower latency? Are you mostly in an offline scenario, or connectivity is an issue? Like maybe you're on a factory floor and you know, you don't always have that connectivity. Maybe you want to be able to quickly do processing on the edge. Or even if you want to do all this video processing, like you have security cameras, and instead of sending all that data up to the cloud, where it can start to becoming more and more expensive to do that because you're sending tons of information up, maybe you want to do it on the edge side, and that way you only send up relevant data that you want to go ahead and send up to save on pricing. Another thing is privacy. Example, I worked with a partner that's public now, but we were doing video processing on the edge, and due to regulations and privacy and GDPR, we needed to make sure that all the video processing of this autonomous vehicle that was happening when we're collecting data, you know, that video is capturing people's faces, you know, right? People have a right to privacy, and making sure that we're not sending up data up to the cloud that could harm that regulation, or protecting the IP on the device side. So there's a lot of really things to understand. Does this make sense for your solution? Down the road, are you looking to expand on that as well? What are the hardware considerations you need to think about? Because you could start off with a piece of hardware that maybe, you know, down the road that you're going to have machine learning models on there or expand the capabilities, and then you release it and you then bring in those capabilities in there. But if you start with a small device and then try to bring AI, and you realize you have to store the data and the device is already made, it can get really complicated. So there's a lot of great material out there, and some white papers on if you're, you know, if it makes sense to have intelligent edge and bring it to the device side. I'll do a plug. You could go to Microsoft Azure IoT Edge to look at that, but there's a lot of other great resources like Edge Impulse and others that kind of talk about when it makes sense for your solution.
Okay. Thank you for sharing that, plug.
As a machine learning person, or at least with some background in it, I would say it's talking to a professional, because some people are taking it. You have a lot of times people are trying to solve simple problems with the wrong tool, right?
Yes.
Like some of this machine learning can totally run on a fairly small processor. You don't need like if you do it right. So I would talk to a professional, understand like what the problem is and what tool is the right tool, like what machine learning approach is the right approach beforehand, and then have a good product manager too. And maybe the customer doesn't really care that it does this.
Yeah, I love that you mentioned that, Kat, because I've seen so many times where people are like, we got to deploy this ML model on this microcontroller to sense, you know, if the lights, like for example, a smart light bulb. And it's like, do you really need a machine learning model for that? Could you just get a basic light sensor to, you know, go ahead? There's being able to identify other solutions where it would make sense. Yeah. I see too often people want to do that kind of the buzzword of it, where it doesn't actually make sense.
We're really running out of time, so I'm going to say we're going to have time for just one more question. While I ask this question, our panel members have told me that we can you can feel free to contact them directly using the contact details shown in the slide. And so the last question is going to be, how can the B2B and B2C market work? That's business to business and business to commercial, when the standards aren't defined, and what should we consider when making business strategy, since the lifespan of products is so very narrow these days?
I'll go first. I personally think we should have a return to standards. Like I do think fundamentally the engineering eras where like the IEEE built standards, and they weren't always perfect. The vendors weren't always perfect with them. But at least you had sort of a neutral party advocating for things. The way we've been building things for about the past 10 years is like one company does something and then all of a sudden it becomes a de facto standard and everyone's trying to catch up. So I do think that moving towards standardization, even if it's just like an open standard, like, hey, this is roughly what we're thinking, I think is a better approach.
Okay, I feel really bad about this because we've got so many questions that have come in. So I really managed the time very badly here, and I'm sorry. But for those of you who posted questions that weren't answered, we're going to forward those to the members of the panel so they can follow up with you later. As a reminder, this recording will be available for on-demand viewing starting tomorrow, where it will be found on IoT Central. That's iotcentral.io. And I'm afraid I'm going to have to bring the webinar to a close. So I'd like to thank everyone for attending and for all your thoughtful questions. A special thanks once again to ARM for their sponsorship, as well as to our panel members, Joe, Pamela, Ihor and Kat, for their insights into today's topic. Once again, this is Clive Max Maxfield, and I'm very pleased to be your host for today's event. I look forward to seeing you all again on the next IoT Central webinar. And so until then, from all of us here at IoT Central, we hope you have a wonderful rest of your day.